Namaskar, good afternoon and welcome to CIET NCERT's another live and interactive session. My name is Deepak Mishra and you are watching us live on PM eVidya channel number 10, and apart from that you can also connect with us on our official YouTube channel which goes by the name NCERT Official. So dear students and all our viewers, today we will be discussing on an important topic for class 10 students and subject is science. जी हाँ, आज हम विज्ञान विषय पे बात करेंगे एक बहुत ही महत्वपूर्ण टॉपिक पे जो कि है चैप्टर 9 लाइट रिफ्लेक्शन एंड रिफ्रैक्शन. इन डेप्थ वी विल अंडरस्टैंड, हम समझने की कोशिश करेंगे रिफ्लेक्शन ऑफ लाइट इमेज फॉर्म्ड बाय स्फेरिकल मिरर. हम बहुत इन डेप्थ में कोशिश करेंगे समझने की. बिफोर दैट आप अगर हमारे साथ इस सेशन के दौरान जुड़ना चाहते हैं तो आप हमें कॉल कर सकते हैं 8800440559 पर, या फिर आप हमें ईमेल भी कर सकते हैं ऑन dth.class10@ciet.ncert.nic.in. So dear viewers, join me with the guest who had joined us. हमारे साथ सेशन में मिस अनुराधा माथुर मैम जुड़ चुकी हैं जो पीजीटी फिजिक्स एंड रिटायर्ड हेड ऑफ डिपार्टमेंट इन फिजिक्स फ्रॉम मॉडर्न स्कूल वसंत विहार न्यू दिल्ली. अनुराधा मैम, वेरी गुड आफ्टरनून एंड नमस्कार. एंड अपार्ट फ्रॉम दैट आप हमारी इंडियन साइन लैंग्वेज इंटरप्रेटर को भी देख रहे हैं. हर नेम इज़ भूमि, जो इस सेशन में होने वाली सभी बातचीत और एक्सपेरिमेंट्स को इंडियन साइन लैंग्वेज में आप सभी के समक्ष प्रस्तुत करने में, बताने में मदद करेगी. वेलकम भूमि. सो लेट्स स्टार्ट दिस सेशन. अनुराधा मैम, आई एम वेरी एक्साइटेड. आज हम जो हमारा इंपॉर्टेंट टॉपिक है लाइट रिफ्लेक्शन एंड रिफ्रैक्शन, कुछ एक्सपेरिमेंट्स भी हम करेंगे और मैं बहुत सारे टीएलएम्स भी देख रहा हूँ. मैम, क्या पढ़ने वाले हैं हम आज?
Basically we are going to talk about reflection of light because that's the most important thing and that's how we see things. So I will start my presentation for you and we will run through some of the very important and key things. Much of it you might think was what you had learnt earlier in your earlier classes, but we still need to give it a second thought. So here we go. What all will we consider? Reflection of light and what happens when light strikes an object, and some laws of reflection we will revisit, regular and diffuse reflection and types of polished surfaces. We will key in on talking about what really is a spherical surface. Is it the same as cylindrical objects or cylindrical surfaces, or is it something different? Then we will also talk about the image. There are so many images that we encounter every day. Some of them are real, some of them are virtual, some of them we know how they are formed and others we don't. Then we will also do one more thing, and that is talking about a ray of light. That means because we can't see light coming to you from any of the luminous sources, you don't know how it's coming to you. So because it is reaching you, you say it is coming via a ray,
right,
and that is just a line and an arrow attached to it which will just indicate from where it is coming to you. So not necessarily light walking on that track, it means it's coming. And why are we taking ray optics? Because that is the simplest way of talking how light reaches you. So let us see, when you talk about a luminous object, sun and all the lights that you work with and others which are not. So in a dark room you can't see any object at night. What is the reason? The light is not there. Second thing is that in the evening you can see in all the objects because you are using artificial light. There is yet one more thing important, and that is the direction in which you are viewing the object. If you have something behind your head, you cannot see that because the light reflected from it is not reaching your eyes. So both things are important to see any object in the absence of it being a luminous object itself. So you need to have light falling on it, light reflecting from it, as well as that reflected light coming and reaching your eye. So when light falls on an object, what really happens? Three things happen. Some of it is reflected, some of it is absorbed, and some of it passes through. So you use the words reflection, absorption and transmission. How much of that happens for any surface depends upon the color, texture, transparency, temperature of the surface. Then the light falling on the object is called incident light, so that we distinguish between incident and reflected.
Okay.
And the one that is thrown back or bounces back, that is going to be your reflected light. And what is absorbed is taken up by the objects and it's converted into other forms of energy. Some of it you are aware of, like heat. When you put something in the sun, it gets heated up. How come? Because it has absorbed the light from the sun and that has given the temperature to increase, and so that is how we. Now, what exactly is reflection? Everybody says bouncing off of light. Sure it is. That means when light falls on any surface, it just bounces back. Now, it means that reflection causes a change in direction of light. If light is moving in this direction, it is going to change and maybe return along the same path or at any other angle. All surfaces and objects that we can see are reflecting. Now, ray of light, as I explained, is a line with an arrow representing the path of light reaching any object. Now, if you take a closer look at reflection, some surfaces are shiny, others are not. The shiny ones are having some kind of regular reflection, while the other one is the diffuse reflection. So, what is so special about reflection? Let us take a look at that. Some of the key terms that we use when we talk about reflection is that there is a normal at a point of incidence. Now, light is falling on the entire surface. So, what is the meaning of this normal and what is the meaning of this point of incidence? Because you need to talk about what happens to the light once it is striking that particular surface. So, you need a reference, and that reference is the normal at the point of incidence.
Okay.
And that is why you take it as a 90-degree point. Then you are deciphering between the incident ray and the reflected ray, and therefore, you need to also talk about at what angle is this incident ray coming. So, you say angle of incidence. So, look at this picture over here. You have a point of incidence O and you have a normal to the surface which is marked normal N, and the incident ray which is reaching it at an angle I, and you have a reflected ray and you have an angle of reflection, and now we need the law. So, what is the rule? Law means what is the rule? How does it follow some kind of rule in order to do a reflection? So, let us see. The laws of reflection is the angle of reflection is always equal to the angle of incidence. So, for all surfaces,
okay,
the angle of reflection will be equal to angle of incidence. The reflected ray and the incident ray and the normal to the surface at the point of incidence all lie in the same plane. Now, take a look at this. This is how it would be. The flat portion to the surface is basically a plane which is containing all three of them.
Right.
Now, you might wonder that most of the books, everybody says angle of incidence is equal to angle of reflection. Why are we saying angle of reflection is equal to angle of incidence?
This is a thought which is coming in my mind, because since when I was child, even I had also read and understood that it is peril. So, you are explaining in a different term that what exactly law of reflection is all about.
Yes, and that the reason for that is that we have to make the law for how the reflected ray will go, and not talk about it can be incident at any angle.
Obviously.
So, how is it going to reflect will depend upon the angle of incidence. Though mathematically angle of incidence is equal to angle of reflection, but not physically. Physically, angle of reflection is followed by the angle of incidence. So, angle of reflection is equal to angle of incidence. Does that make it clear?
Okay, so mathematically it's perfect, but physically it's
No.
not. Okay, this is something new which I had learned today.
So, let us see, let us go on. Look at this. Now, the images that are formed
Yes.
on account of reflection. Here is a still lake and you see all the trees and everything upside down.
Right.
Now, if you recall how the image was formed in a plane mirror, if you had an object Then you took 2 rays, minimum of 2 rays, and you allowed them to be incident at any random point on the mirror, and the reflected ray following the laws of reflection, and you made the reflected rays. But they would never meet. They would be diverging from the surface.
Correct.
So they will not ever make a real image, and the image formed in the plane mirror was behind the mirror, and it was virtual. There were more things to that image. The image size was exactly equal to the object, but there was another kind of inversion, and that was termed as lateral inversion. Watch over here, the no and the no image. The O is coming in front and the N is coming at the back. However, the size of N in both and the size of O on both is the same.
Right.
So the image is erect. So what is the meaning of lateral inversion? Look at this. Here's a picture in which the hand in which I have the watch, I have taken this picture in a mirror and I am holding it like that, and it seems that the image has its right hand coming up. I had the left hand up and the image had the left hand. But remember, this is not an inversion that has happened, which you say that okay, left is becoming right and the right is becoming left. That is not happening. So it is a virtual image, it is erect, it is the same size, it is as far behind the mirror as the object in front of it. Laterally inverted means my left hand with the watch appears to be right hand with the watch in the image. Okay. So the image is erect, and this is the meaning you have understood. And can you use this figure to explain how this lateral inversion is taking place? If you draw it yourself, you will see that the image is formed as far behind the mirror as the object in front of it, and that is the cause for this inversion. Any other condition?
Might be there could be, like if I am standing at my home in front of my bed and there is a big size mirror. So I will be doing the same experiment. I will be just keeping my left hand to that mirror, and eventually what you explain that it will be showing like left becomes right and right becomes left, but
Yeah.
actually it doesn't.
It doesn't. Okay, think about these. Here's a very simple
This
question.
is a perfect example, ma'am.
In this one, the trees, say supposing, have a height of about 8 meters and the depth of the lake is only 3 meters.
Right.
So how are you getting the reflected image?
Big question.
There is just no space for the image to be formed, but you are getting the image and it's looking very nice.
Right.
So you have to think about it. Then look at this one. There is no mirror over there and this is just a little hole, and in a pinhole camera you get an inverted image, and it's pretty clear as well.
Right.
So how is this one formed? That's also your job to think.
Right.
So we observe reflection from all the surfaces around us. Whatever we see, it is all going to be like that. But are they all plane surfaces? No. So let's take a look what's the type of surface that we have. Now over here we have some curved surfaces, and you can see all these, some objects have just randomly picked up, and you can see that there are so many of them. Some of them are shiny and some of them are not, especially this tennis ball.
Right.
Yeah, it is not shining, but you can see it.
Right.
And what about this one? In this one you can see image on both sides, but it looks different. On
Right.
one side you are getting an erect image, on the other side you are getting an inverted image. You just have to look at something like that in the kitchen. This one has some portions which are shiny, others which are buffed,
Right.
as they call it, or so there is regular and other diffuse reflection taking place simultaneously. This shiny ball is reflecting quite nicely.
Right.
So let's see what is, these are all curved surfaces. So would all the surfaces be curved and they will reflect light? Will the laws of reflection be followed in every case? Would an image be formed in every case? We saw that the tennis ball will never give us an image. We can never see it shining, but a car will. A polished car, you can see yourself, it's a curved surface.
It's a curved surface.
Yeah, but it's not a spherical surface. A spherical surface is the one which is curved, but is a part of a sphere.
Okay.
So, this is a special case, and this is what you study in your class. What you do is you talk about concave mirror and convex mirror, and in that you are able to see the images and see what are the different ways the images are formed and how you can utilize it, because if you are able to see it well and understand it well, only then you can apply it. You see a lot of curved mirrors and spherical mirrors around you. So, we will only concentrate on spherical mirrors, and you see that the center of the mirror is called the pole. Now, I have a mirror over here, and this center would be called the pole, and the radius of this spherical surface, say for example, if it was part of this ball, then the radius would be the radius of the ball.
Okay.
Yeah, like that. So, then line joining the pole and the center of curvature is called the principal axis. What do they look like? They would look like this. That means they would have a flat, looking like a flat surface, and reflecting surface is spherical. It can be termed as with a circular outline, and the diameter of it, this one, this is called aperture. Watch, here is another one, but it is much smaller. Its aperture is less than the one which I am holding in this hand. So, the two mirrors have different apertures, if you can notice properly. Then there are also a possibility that the bulging out surface is part of the outer portion of the sphere, and it could be the inner part of the sphere. So, you have two names there, concave and convex. Concave means the one which is inside, that is this side, and the convex is the one which is outside, that means this side. So, this spoon could be talked of as having a concave surface as well as a convex surface. Both things are there in this spoon. So, we are dealing with spherical mirrors in our class and in our course, and we are going to only limit our study to those which are smaller, which have a small aperture as compared to the radius of curvature. So, you talk about a focus, which is a point on the principal axis where rays coming parallel to the principal axis converge to or seem to diverge from. That is the meaning of focus in the case of spherical mirrors, and it is denoted by a capital F, and the distance from the pole to that focus is called focal length. So, you might have heard people talk about focal length, etc. Here is another diagram which can just relate all the words that I have used just now, and there is a relation between the curved surface radius of curvature and the focal length. So, radius of curvature is twice the focal length and only for small aperture mirrors. Now, here is two images, one is a convex mirror and the other is a concave mirror, and you can see in the convex mirror you always get a vertical or an erect image, and in the concave one you get an inverted one. Have you seen any of these in real life? Used it at home or anywhere? In the car, the mirror that you have, the rear view mirror, that is convex, because you see small things coming from the back. All the cars at the back are the same size probably as any other on the road, but when you look at them through the mirror, then the reflection shows them as small. It makes you feel that you can see more, and that is what its application is. The concave mirror is used also in the bathroom, sometimes as shaving mirror, because you want to see a larger portion of your face so that you do not cut yourself.
Right.
So, two types of images you will be working with, real image and a virtual image. So, real ones are the ones that you can receive on a surface because it is formed by rays converging to a point after reflection. However, virtual image would be the one in which the rays actually do not meet, like we saw in the plane mirror.
Right.
And what happened there was that they were diverging from a point after reflection. So, that is why you have real and virtual image, two names given over there. This is an activity which you can try yourself. get yourself a mirror which is available in the market as a cosmetic mirror, and take a candle and move it in front of it back and forth and see how the image changes.
Right.
It will be very interesting for you to do that, and you can even do it with a spoon in the, or a big spoon like the one I have from the kitchen, and that is also possible. Now, this is a kind of a table which is in your book. We will talk about it later.
Okay.
Yeah.
So, ma'am, I think today we had covered a lot of things, especially we had learned a lot of things. And one thing, the law of reflection, I'll not forget this, because in my life I haven't read or haven't heard about that. So this was something interesting, and as ma'am had given us some interesting activity as well, that you can go ahead to the market, you can purchase the mirror, and you can just go with some basic activities. So ma'am, before winding up and wrapping this session, I would request you, ma'am, in upcoming session, what we will be learning and what all things you will be teaching to our viewers.
I
Please
will.
tell
I
us.
will. I'll give you some homework before that, and let us see some fun things. One is, you take a picture, take a selfie of yourself using your phone, and extend your hand so that you are doing shake hand, and do the same with your mirror and see which image allows you to do shake hand. Then this story, figure out what it is, a story of a dog who was crossing a bridge with a piece of bread, and he sees another dog and barked, and the piece of bread fell.
Right.
Now you have to explain what could have happened. Then if you go around a parking lot and see your image in the car surface and see what type of changes are happening over there, you can do that. While laterally inverted image, try and figure it out yourself. And what we are going to do in the next episode or next meeting with you would be that we will consider how the image in a concave mirror and a convex mirror, both spherical, are going to change with the position of object in front of it. You would have done your activity and you would have tried it out, but we are going to use rays to try and see and figure out whether you did the right thing or not. So that is coming up.
I think this would be very interesting activity. We will be covering up in upcoming next session with the same guest, Anuradha ma'am. And today we had learned and understood a lot of things today, especially the light reflection and refraction in terms of convex and concave mirror. And in next session we will be discovering and learning a lot of things. Now the time is not allowing us to continue this session, so we will be wrapping this session. Before that, I would like to give thank you to Anuradha ma'am for joining us and explaining this topic so beautifully. Thank you so much, ma'am. And I would also like to thank our Indian Sign Language interpreter Bhumi for explaining and joining this session to understand this viewers in the form of Indian Sign Language. Thank you, Bhumi. Important announcement for the students of grade 4 and 7. Now you can go ahead and purchase the textbooks. They are available online on Amazon and Flipkart, and also on NCERT's official website. And now have a let's quick look on upcoming sessions, what all sessions you will be watching on today PM eVidya channels. So after some time at 3:30 PM there will be a session on Sanskrit subject. At 4 PM there will be a 1-hour online training. At 5 PM there will be a session on Sahyog, and lastly at 5:30 PM you will be watching session on NEPA on an interesting topic. So this is me, Deepak Mishra, now wrapping up with this session with the commitment that we will come back once again with another session, same guest, and we will be learning and understanding a lot of things. Till the time, take care of yourself, keep smiling, keep learning, and keep watching PM eVidya channels. Namaskar.
Jai.